Mathematics is fun, isn't it?
Yes, miss.
Daryl, I want you to tell me something that you learned that you took home with you and you made use of it.
Okay. The last class that I learned how to find the mean of some class scores that I had previously. I made use of it by trying to figure out what I need to improve on and so on.
Very good, very good. What about you, Stefan?
Well, from the last class, I learned how to find the mean, the median, and the mode of scores. And instead of being mean to others, sharing the meaning of the word mean.
Oh, that was good, that was good. And you didn't go and telling anybody that they were the mode? Did you, Delicia? No? Okay, I'm glad you didn't tell anybody they were behaving like the mode. Yannick, you want to tell me any way in which you benefited?
Mr. benefit from knowing the meaning of the mode, mid, and medium. The mode is the number that appears most frequently in a set of numbers. And the median is the number that is in the middle, is formed in the middle of a set of numbers.
Oh, so it's like butter in between two slices of bread.
Yes, miss.
Okay, and you were the butter. Okay, well, I'm glad that you're finding mathematics fun. And remember, I always say, always fill your mind with something that is nutritious. It's better if you tune into Channel 80 and you listen to either the Spanish or the Math in Focus or the physics, and you fill your mind, that garden that you would need for future. Fill it with something that is educational and enlightening. And the returns would be numerous. Now, we've been looking at statistics, and we started at some very basic concepts, and then we built on them. After coming out of the realm of the mode and the mean and the median, we looked at frequency tables, and then we plunged into ungrouped data. And we looked at the limits and the boundaries and all of that. Now here we want to go one step further. And we want to take the information from the frequency table, which is grouped, and put them on frequency polygons and histograms. We want to show our information in a different way. We don't just want to leave it on a frequency table. So our main focus is to create histograms and frequency polygons. So we're creating histograms and frequency polygons. So here we're going to take some key points. The histogram, when we look at the histogram, we're going to see it as a graph. And on that graph, we're going to notice some bars. And there's no space left between the bars. Also, we'll find that one of the best way in which we can show or illustrate information on a frequency table, or if we have a frequency distribution, is by using the histogram. Now, what is a histogram? A histogram is a technique, or a histogram is another way in which we can visually present information. And this information that we want to present is presented through the use of bars. We make use also of our groups or our classes and the frequencies with which those classes occur. So here we have a histogram is a diagram that is used to display the data contained in a frequency distribution. A histogram is not a bar graph, because in a bar graph, the bars are not close together. They're not joining. There's space apart. There's spaces between the bars. So do not mistake a histogram for a bar graph. In a histogram, there is no space between the bars, and the width of the bar is the same. Now remember when we were looking at the size of the classes, and we say the sizes of the classes are all the same. They accommodate the same amount. If we have 10 numbers in the first, we should accommodate 10 in the second, 10 in the third, and so on. That helps us to understand why we say the width of the bars are all the same, because it's the same amount. Like in the one at the last one, we say the size of the class is 6. All classes will be 6. That size would be 6. So that helps us to understand why we say the width of the bars are all the same. Now let us look at example 1. There we have some marks gained by 50 students in a social studies test. The highest mark was 20. Here we have a lot of marks. 50 students. So we're going to have 5 by 10, and that gives us 50. In this situation, we are given our class intervals. So we say we're going to accommodate them as 1 to 4, 5 to 8, 9 to 12, 13 to 16, and 17 to 20. How many classes are there?
5.
5 classes are there. So we're going to distribute our data into those 5 classes. So here we have our first class interval, our second class interval, third, fourth, and fifth. So if I ask you to look at my second class interval and identify the upper limit, what would the upper limit be?
8.
Upper limit is 8. Very good. So if I say now, I have the upper limit as 8, what would my upper boundary be?
8.5.
Very good. Excellent. 8.5. Now, you would have added a 0.5, but another way was to take the two limits, sum them, and divide by 2. 9 and 8 would give us 17, and we divide 17 by 2, and that gives us 8.5. Very well. So let's look at the solution now. We need a frequency table from that information where the 50 student marks were collected. So we grouped. So we have our classes on our left, and we found that 19 of the scores fell within 13 to 16, and 7 of the 50 scores fell from 5 to 8. So if I'm to ask the question, which class is the modal class, which one would you identify? Which class is the modal class here? Of the 5, which one is the modal class?
13 to 16.
13 to 16. Why 13 to 16?
Because it is more frequent.
Because it is more frequent. I want a better answer than that.
Because most children score between 13.
More students scored from 13 to 16. Most of the students scored. So we have 13 to 16 being the modal class. Yannick, which one of the classes you would have wanted to fall into?
13, 16.
13 to 16?
Yes.
You would have wanted that here? No, where would you have wanted to be? Exactly, I thought so. I thought
shoot.
so. Okay, let us continue. Example 2. The frequency table displays the marks gained again by the 50 students in the social studies test. The highest mark was 20. So there we have our table again. And we want, after having our table prepared, we want to take this table and put it in the form of a histogram. We want a histogram to show this very information now. Remember, we say a histogram is this diagram that gives us a reflection of what is on the frequency table. And this diagram makes use of our classes and the frequency. Now let us see what the diagram looks like. So here we're saying that with a histogram, we take the information from our frequency table and we demonstrate it here. And remember, the groups or the classes are always on the vertical axis. Remember what we're saying, that I'm emphasizing that the groups or the classes are always on the horizontal axis, and the frequency will be along our vertical axis. Okay? Remember, the bars always kiss each other. There is no space between them. And you cannot give each bar its own width. So you make one bar here, and then you decide that the other bar should look like that. And then you take this one and you take a half there. No. Every bar must have the same width of each other. All the bars share the same width. The only thing that is different is where the frequency ends, whatever the frequency is. So this frequency must correspond to the group or the class. Remember that. Now that was for histograms. Now we don't only have to take histograms to display our data. We can also make use of another concept or another graphical display called frequency polygons. Now, what is the frequency polygon all about? It's another way of representing a frequency distribution. Read for me.
A frequency polygon is constructed by the lines joining the midpoints in each of the top lines of the rectangles on a histogram.
So what do we need in order to construct this frequency polygon? We first need a histogram. And we're going to take that histogram, identify the center of each bar, the top. We go to the top line and identify the center of it. And to form this histogram, we go ahead and we join each one of them to the other. So let's see how we are going to construct this frequency polygon. So first of all, we have to get our information. We have our classes. And here we have our matching frequencies. Yes, so we're looking at our frequency polygon. And as I said, it will not be a polygon unless our shape is closed. So we begin at this intersection here, and we identify our center points that corresponds with the frequency and the top of our bars, and we close off. So we join our lines point to point to point to point to point, and then we close off there. Now you might be wondering, why is it we close off? How do we close off there? Now, if we had a sixth class, 1, 2, 3, 4, 5, if we had a sixth class there, then the width here would have been the same across here. So we average the halfway mark and we close off at the end there. So here we have our frequency polygon. A frequency polygon is formed when we join consecutive midpoints of the tops of the columns of the histogram by straight lines. Now again, we said we need a histogram to guide us into getting a frequency polygon. But when we look at the two, what can we say of the area of the histogram? What can we say of the area of the histogram and the area of the frequency polygon? So here we have the frequency polygon. And here we have our histogram. And we have a certain area under each. What can we see about them? Let us look at the histogram and compare it to that of the frequency polygon.
Passes through the midpoint.
Yes, the histogram does pass through the midpoint, but we're looking at the area. the area would be the space under each. Let us compare the areas of the two. The space under these bars, or within these bars, as compared to the space under the histogram. That's the space under the bars. Compare that now to the space under the green outline, and tell me what you notice.
They cut the same.
They cut the same.
They cut it the same.
They all cut it. It cuts everyone at the midpoint. But there's another difference. There's something else that we can look at the two and say as it relates to the area. Now when we say area, we're looking at the amount of surface enclosed here. This is the surface or the area of this shape.
That's the same amount of surface area that the histogram takes and the same amount of surface area that the frequency polygon takes.
What do you think, Ayana? That's delicious observation. What's your observation?
It's about the area of the histogram
And the frequency polygon.
It's the area of the histogram is more than the area of the polygon.
The area of the histogram is more than the area of the polygon. Ivana, you want to give it a try?
I think the area is the same.
You think the area is the same. So let us see if we can accept which one of the two propositions we can accept. So let us see. Maybe this piece here can match up with this one. Yeah. And maybe this piece here can match up here. And I think if we go all around, we'd see that exactly what is in the histogram is under the frequency polygon. So the area is the same. Very good, Delicia. Very good. So there we have it. The frequency polygon has the same area as the histogram. Now what else, after we would have drawn in our lines to give us our frequency polygon, we notice that, for example, this line in our first bar, on this end here, we have a three-sided shape, which is called a
Triangle.
And then, when we look at this one here, it is four-sided, and we call it a trapezium. And then, let us look here again. What is that we have there?
A triangle.
And let us take here, and then we'll go around. Let us start from here, and then we go there, and we go across, and up, and across. What do we have there again?
Trapezium.
Another trapezium. So after we would have obtained our polygons, what we have, the enclosed regions are made up of triangles and trapeziums. What else do we notice? Yes, the area under a frequency polygon is directly proportional to the total frequency of the distribution. And if we should get rid of our histogram, this is what our polygon would actually look like. So here we have our centers. These points represent the centers of our bars. Another one here, and then we close off there, and we started at this intersection. So the diagram shows the area enclosed by the frequency polygon and our horizontal axis. So the polygon is seen much better there now. Okay, we don't have the bars to affect us. So we were looking at frequency polygon and histograms. Now before we could have displayed or shown you information on those two, we would have had to look at the frequency table. And the frequency table displayed the information in group form. We saw classes, and those classes can help us with our limits and our boundaries and our class size. And also on that frequency table, we can identify our modal class. Now in a histogram, there is no space between the bars. That is why I say they kiss each other. And when you kiss, you are having one surface connecting to another. No space, it's not like a bar graph. What we also found is a frequency polygon is constructed by the lines joining the midpoint in each of the top lines of the rectangles on a histogram. Then the frequency polygon has the same area as the histogram, as we observed. And the frequency polygon has the same area as the histogram. Now again, I cannot send you off with just what was taught. You need practice, you need reinforcement. So for today's lesson, you are going to go to that textbook, Mathematics for Secondary Schools in Guyana, book 3, and page 130, you will find exercise 9E, where we're taking questions 2 and 4. But there are other questions, so make sure you complete the exercise. You're going to be a master at statistics. Then we also need to look at the problems that were given in the last lesson. So let us examine the solutions, which I know you conquered. On page 109, exercise 9D, question 4 asks you to identify the size, the boundary, and the limits of the class interval 1 to 5. And I know you aced that. For the solution, I know you had the size as 5, the boundaries as 0.5 and 5.5. Here we have the boundaries, 0.5 and 5.5, and the limits as 1 and 5. Excellent job. Very good. For the second question, you have to write down again the size, the boundary, and the limits of the class interval 20 to 25. And I know you got the same answers as in our solution. The size of the class is 6. The boundaries were 19.5 and 25.5. Here we have our lower boundary and our upper boundary. And then our limits were 20 and 25. And again, we have our upper limit and our lower limit. You're doing an excellent job at home. So here we have the information of the 30 students displayed, and it's recorded in seconds. And the classes that are required begin from 25 to 25.9, 26 to 26.9, and so on. So we want a frequency table to reflect that information. It looks really confusing as it is. And I know that you already have that frequency table waiting there for our solution. So here we have the frequency table, which I know you have in your booklet there at home. You have your classes there. The first being 25 to 25.9, and the final one, which is the 9th one, being 33 to 33.9. The corresponding frequency of the final class would be 2, along with the tally. And I know you can look in your booklet and you can tell me that the modal class is 29 to 29.9. Why? Because 14 students in that set, their times range from 29 to 29.9. We had more students in that group of timing. So we say that was the most popular group or the most popular class. Now let us also use this frequency table to talk about some other things or revise some other concepts. Remember we said that after we got our classes, it is from our classes that we get our limits, and we also get our boundaries. We take our limits as we see them on the class. So we have our lower limit and our upper limit. And then our boundaries would be a manipulation of our limits. Mathematics is indeed a beautiful subject, for we can take information that looks very confusing. And some people might ask, what is really happening there? Talk to me. And then we can make that same information put on wings like a butterfly. And then it begins to fly, and then we see tables popping up. And then that table becomes a graph, and they say, wow, don't you like histograms and frequency polygons?
Yes.
Yes, for they gave us meaning and they gave us life, and they put life into what we're looking at. Mathematics is indeed wonderful. Keep on learning it.